What's the name of the Google Plus page?
I think it's Unicon, and there are sub-pages up there for developer forum. And that's where I put the link.
You're in the Unicon page. You need the Unicon community.
Oh, it is March.
Time flies.
Yeah.
Yeah.
So you want to mute your speakers too.
Is that, can anybody hear me? I think I see my stuff. Moving this crap on me.
The other people are Bradley or whoever. Type in chat. You should be able to watch chat in Google Plus. Just get confirmation from someone else that's in the Google Plus that they can hear.
This is what I can never, like, for some reason the chat window, kind of, or the little chat sidebar kind of disappears, and I don't know how to get it back.
You don't have the, there should be icons on the left-hand side.
Yes.
One of them should be a chat.
Ah, there it is. Okay. I see Bradley Gore says I can hear.
Okay.
Yep.
You should be fine. Can you see?
Can you? I guess you might have to share that if you like. There's that little green.
Should be sharing.
Yeah.
Oh, that's exactly what I have up there.
You all set, Andrew? You good?
Yeah, I think so.
Okay. I did want to take a few minutes. Hey, everybody, welcome to March Software Dev Forum. We're going to do a few things different today. I guess one of the big things we're going to do, we do want to take a second or two or a minute or whatever it takes to do a quick critique of presenters. In this case, it's just Andrew today. I know we talked about that in our kickoff. Also in the room, I see a lot of devices and laptops in here. I know we talked about that. Don't want to be a jerk, but remember we want to be supportive of our presenters. We don't want to pretend like if you got work to do, if you got deliveries, deadlines and all that, just maybe don't even come. But we're trying to keep attention focused on the presenters. I know we talked about that. So again, please be sensitive to them. This is for you and them. So anyways, today's presentation is do I say it Kubernetes?
Kubernetes.
Kubernetes. They understood it. All right, take it away.
All right. So one of the big pushes we've been having lately within Unicon, obviously, is the AWS environment, and kind of I think along those lines, a lot of people have been using Docker, and so I've seen Kubernetes a couple times and thought it would be really cool to look into. Primarily, it ends up being a container scheduler, kind of a replacement for ECS or something you could use on AWS instead of ECS, but you can also use it elsewhere. So I've looked into it a little bit, and I thought it'd be really cool to go through that and kind of show you guys what it's about. So, yeah. Cloud native computing is something that you'll see a lot if you go to the Kubernetes website. It's kind of the whole goal, and it's based on essentially, or at least Kubernetes is based on what Google's been doing internally for about 10 years now. And so cloud native is kind of a term that they've coined. We have the CNCF, Cloud Native Compute Foundation, has defined this term, and if I'll put these. Actually, these are up on GitHub right now, but I don't know how up to date they are. But you can go check out that link later. So the three things that need to apply for something to be considered cloud native is that, first of all, your pieces are container packaged, so Docker is the common way to do that right now. Dynamically managed, meaning you're not manually spinning up instances of Docker or spinning up containers as you go through your deployment or through your development workflow. That should be dynamic. And then microservices oriented. So I don't know if we've had to talk about that yet, but I think microservices really kind of self-explanatory, really small services that are doing one thing. And then communicating with each other when you need to do something else, kind of orchestrating those together. So as far as container package, that if you look at the open containers spec for containers, technically for bundles, is what a Docker image would be. That consists of a file system bundle, which is essentially what is going to be the root directory of this container when we start it up, and then a config.json file, which is going to have stuff like if you put in your Docker file exports port 92 or whatever, that's going to show up in the config.json along with, what's the command, what are the arguments, what are the environment variables. The two common image formats out there right now are Docker and then Rocket, which is a newer one. Tries to be a lot simpler. I think it's just kind of a tarball versus Docker, which is those like crazy layers, and just cool, but it does get kind of complex sometimes. So dynamically managed, meaning containers should be actively scheduled and actively managed by an orchestration process. And I'm just taking these definitions straight out of the CNCF document, I guess. So in this case, Kubernetes would be the manager there. And microservice-oriented, loosely coupled services with explicitly described dependencies, and the example they gave was service endpoints. So you would see that with like a REST endpoint or an RPC endpoint. So I'm going to go give a quick demo if that's all right. It's actually going to be a little kludgy here. Stop sharing. How am I going to share my entire screen? Collapse this down. All right, so is that visible?
Yep. As much as black is
Very small.
It is small.
All right, is that better?
Yeah.
All right, so I take this all down first. So one thing you'll find out if you end up playing with Kubernetes is there's a lot of different objects that you create and a lot of different definitions that you keep. So what I ended up doing as before I discovered this other way, is I was just making a make file that kind of iterates through and essentially uses all these files that are definitions of your services. And so on my make file just kind of iterates through. It's really simple, kubectl create, and then whatever that file name is. And then those are all managed in a YAML file, which I think people will probably be familiar with from Docker Compose. So I actually have another service running right now, or another little application that I was going to demonstrate. But you can see there's a couple things running right now. And I'll give a quick, this is just going to stand up uPortal and make it available with an HTTP proxy. So what I've done here, it's called a replication controller. It's going to make sure that there's one replica of this container always running. I give it a couple labels, and then here's the spec. sorry, I moved my cursor around, but I'll do the mouse. So I have the spec here, which says each container is going to look like this, or each instance of a pod is going to look like this. So first I give it a name. Here's the image I want you to pull. I always want you to pull down the image. We have a liveness probe, which is going to make an HTTP GET to this path, this port. The portal takes forever to start up, so I give it a 240-second delay. And the nice thing that you'll get with this liveness probe is it'll realize that something's wrong with this pod and start cycling it, start killing it off and recreating it. I do believe you get this with something like ECS as well, depending on how that's implemented. I know ours is really, we just made sure I think you can get a TCP connection to port 80, which doesn't really tell you a lot. So what you want to do with any environment is try to make sure you're actually giving something helpful. But yeah, alerts. So resource limiting, I'm going to give it 2 CPUs and 4 gigabytes, and it's going to request minimum 2 CPUs and 3 gigabytes of memory. And that is ports and environments, volume mounts. I'll get into a little bit of that later, but I'll go ahead and try this out. We'll see if the demo gods smile on me. So it's going through, it's creating a kube system namespace and then a DNS service and replication controller, which is what all of the different services are going to use for service discovery. So you actually hit a DNS endpoint. And then the rest of it is we're standing up uPortal database, Memcache, Nginx for the ingress, the reverse proxy, and then uPortal and Redis. So we should see we've got uPortal container creating. This one is probably not going to go, and I'll have to. So one of the cool things we saw, I delete that pod, but since it's not just a container, it's a replication controller, it goes and recreates it. I have a problem where one of my nodes has a service running on port 80, so it doesn't like to run on that node. And what do we got there? Well, I guess uPortal may not want to actually start up.
Fakers.
Yeah. Container, I also have a weird dependency that one's kind of connected to a node that has a file structure. So what you'll run into a lot in cluster environments is some things you can do with Docker Compose you can't actually do on a cluster because your hosts may be completely different. Like if I find a volume that's mounted on my host, which is exactly what I've done in the uPortal one for kind of expediency, it'll only work on that particular host. And so I don't think it's actually gonna work, but so what you end up having to do is have actual globally accessible stuff, like you'll create NFS volumes, or in what you can use in Kubernetes, they have, I think, 2 different bindings. There may be a third for OpenStack, but in Google Cloud and AWS, you would create like an EBS volume, and then you can mount that directly into your container and give it a mount point. And you can also control access policies, like only one volume is allowed to write to this, or only one pod is allowed to write, so that's kind of whoever gets there first, and then the rest can read only, or it's all read only, or they can all read and write, and it's going to enforce locking at the file system level. Hey, there we go.
You said this was like a replacement for ECS?
Yeah, it would kind of be something that you would run in place of ECS, where you give it a bunch of hosts and you run Kubernetes, the agent on all those hosts.
What would be the advantage of doing that?
I should probably go through my slides actually instead of just this.
Yeah, if you didn't get to it,
I will get to that.
If you're not running into Amazon?
Yeah, if you don't want to be, that is one major benefit, is that you're not stuck on Amazon at that point. it just needs computers, it just needs nodes to run on, and ECS can provide, or EC2 can provide that, or you can do, like, I know there's findings for Google Cloud because that's kind of their bread and butter. And then there, I think, are pretty easy bindings that you can run on OpenStack, which is pretty popular. So, let me make sure my host file is pointing to the right place first. So hopefully, if this decides it wants to work, we'll have uPortal running on this backend. First request takes like a minute to go through.
The heat check on that.
Hooray! So that's actually running on a cluster that I've just cycled with that makefile and pulls up. You're probably not at all familiar with the uPortal student service portal, but this is what it looks like. So yeah, that's that's kind of a else.
Demo time. You've gone down the vortex.
So I guess one more thing I can do is I can. So this is actually one of the hosts. Do a quick Docker PS, and you'll see it's kind of messy. It's got like 1 million containers. Whoa. Well, I guess the other thing I wanted to show, but I'll first show this. So let me just. All right, so here we've got the uPortal container. So I'm going to actually just.
Hello.
Yes.
Yes.
And did you have a question?
I'm good. How are you?
Okay. You can go back on mute then.
All right, so I'm going to go ahead and remove that container.
Yes, actually, we wanted to reschedule. I think my husband is going to call you in today or tomorrow.
Nothing like multitasking all of you.
So I'm actually going to figure out what's a different uPortal it's running. So anyway, so another thing I can try to show real quick is the scale command. So what I tried to do is make sure that all those different uPortal instances are able to communicate with a central server so that I can scale them out like this. I'll do something less ambitious, like 3. So I'm going to give it the name of the replication controller, and it's going to automatically start scaling that up to 3 instances. Probably one of them at least is going to fail, since it's going to be needing that post-mounted volume that's not going to exist on one of my nodes. But you can see there it's created, or this is the one that was already existing, and it's trying to create these 2 right now, which is just going to pull those containers. Yeah, container can't have fun.
So replication controller is a Kubernetes entity type thing?
Yeah, it's a Kubernetes object that basically gives you a template for a pod, which is another Kubernetes object, and then some control around that. There's also, in 1.2, which should be out pretty shortly, there's an auto scale to say, kind of like what you would get with ECS, where if the CPU gets pegged and it's using all its resources, it's going to start to scale that up, and you can give it a minimum and a maximum.
Oh, cool.
So Engine uses DNS for node discovery.
Yeah.
How do you handle like multiple environments?
In multiple environments, you shouldn't have you shouldn't have issues with the DNS, because that's just, it's totally managed by Kubernetes, like where those endpoints are going to point.
But I mean, do you have like multiple Kubernetes configuration files for each environment then, or how does that?
That you probably would, but that ends up happening more for volumes. because your volumes are not going to be probably NFS mounts up in the cloud, or it's not going to be a host volume. It's going to be an EC or an EBS volume, and so you would just have differences there. But as far as your instances, those are all going to get load balanced. But I'll get into that really quick. But try to get back.
It's you.
It's not showing right now. Okay, actually just exited it.
I got left hang out.
Yeah.
Well, Andrew's working on it. I put a link comments to a brief write-up on the comparison between Kubernetes and ECS. And one of the interesting things that jumped out to me is this ability to use labels to target container groups, so you can really version a whole suite of services and containers, microservices, and control them and route to them kind of as a unit.
Right.
That is pretty cool.
Yeah. The other thing that enables, or the Kubernetes enables you to do is, that I don't have a demo for, I don't think, is a rollout. So if you have a version that you want to update, and you have, like, say, 20 instances of that container running, you can tell, say, just Kubernetes rollout, rolling update, I guess it's called, and then you give it a new image, and it's going to take that replication controller and start one new instance of your new image, and then as soon as that's healthy, it'll take one down from the old group, and then slowly roll across the cluster. And if it starts to get errors, actually, it'll stop and let you roll back. So if you try to roll out something that's broken, it's going to prevent you from kind of shooting yourself in the foot, hopefully. You can still probably shoot yourself in the foot, but you don't have like a health check in there. So quick containers overview. So they're obviously a file system plus some metadata. When they run, they're using Linux namespaces, which I'll get into that shortly, and that'll be a little more obvious why when I get to the pods. They also use cgroups, setconf, and chroot, which cgroups is for, so I'll go through Linux namespaces. So we have a couple different namespaces in the Linux kernel where you can, when you clone a process, you can put it in a separate or a new namespace. One of the ways, or one of the namespaces that you can do is IPC. So your System 5 inter-process communication or your POSIX message queues can be namespaced off. Network namespaces, so the default network namespace is what you live in every day, but when you create a new Docker container, that's actually a new network namespace, which is why it has its own 127.0.0.1, different local host. And you need to actually do routing into that namespace rather than just, it's a different port on your own computer. UTS, which is the different host names, so your containers can have a different host name, and that's not going to be the same. Mount namespaces, so which volumes get mounted. If I have something mounted on var on my host, it's not going to go into var on my containers. PID namespaces, you've probably seen that if you've done Docker, or if you've done PS inside a container, it's going to have its own PID1, which is usually just whatever your application is, and then user namespaces. Cgroups, used for resource limiting, resource accounting, resource isolation. So Kubernetes is going to use all of those, and I think I'll get into that shortly. So back to, so you saw some of the constructs there in the replication controller I showed off, where you can actually use C groups to do some resource limiting and accounting. So limiting, say, I only want this to use 3 gigabytes of memory max, kind of a thing. Isolation, you're not going to be able to access some other container's memory because we're using a different C group there, which really just stands for Linux Control Group. If you want to look more into that. And then accounting, so you can actually, if say you're a cloud provider, you can get detailed statistics on how much a container has consumed as far as CPU cycles or memory. And if you want to bill based on that usage, you can do that, which I think is actually one of the big reasons this kind of functionality got sponsored. And then, so brief overview of Kubernetes and why I think it's cool. Number one, it's open source. I was talking with George about this the other day. I don't think we'll ever see, unfortunately, ECS get open sourced. So kind of makes it hard for us to get to number two, which is dev prod parity. I know for the SSP project, we're using Docker Compose locally, and then Ops has their own completely separate set of task definitions that are going to run on ECS. And there's a lot of detailed communication that needs to happen back and forth to make sure that they're using the same environment variables, that they set those right. And what Kubernetes enables you to do is those same, like you can run just a local cluster of one on your computer, which is really nice, and that's where I got started out. And then you can use the same configuration files. It's literally just one command line change to switch over to a separate environment. It takes a little more than one command to configure that environment, but once you have an environment, you can just switch back and forth with one command, and then you can deploy on your local machine, make sure it works out, and then send it up to the cloud in your CI environment or whatever. So Kubernetes is a Google Knowledge Share. What they've been doing for 10 years is called Google Borg, which is they've been running everything in containers at Google. And this started as a community-driven project with kind of Google's guidance based on what they've been doing. So they wanted to actually start from scratch, write something that could be used by the community, but with the knowledge and the experience that they've gained by running containers in production for 10 years. As a thriving community, I made the mistake. I've actually resubscribed, but initially it was really overwhelming. I subscribed to the GitHub repository, and it's probably about 150 issues a day that are notifications on GitHub, and I get emails for each of those. So it's kind of crazy. But now it has its own filter, and it doesn't notify.
That's thriving.
Yeah, it's far and away the most popular one I've seen. And I think half of that traffic is bots, because they have like a merge bot to make sure that you pass all your tests before it gets merged in, and so there's some of that going on. So, and then the purpose for Kubernetes, it's container scheduling and orchestration, and it also provides service discovery as part of that orchestration, and it provides secret management, which is something that ends up being pretty useful. Quick architecture overview, it's built on etcd, which, in case you're not familiar, it's just like an HTTP key value store. Uses the Raft consensus protocol, which is distributed systems. Is anybody familiar with Paxos? It's another distributed system consensus algorithm, which is like insanely complicated. And then Raft is a very recent entry, and it's like 10 times easier to understand. But a lot of products have sprung up around that algorithm, and etcd is one of them. So it's a key value store that's highly available. Does master election, and then if one node goes down, it'll re-elect a new master, and you can just communicate with that. So it builds on top of that, where it stores all its configuration. The network model for Kubernetes is that every container should be able to talk to every other container, regardless of which node they're on. And the same thing goes from the node. Every node should be able to talk to any container, so it should have a direct path. And all of that without network address translation, which you can accomplish. I think there's 4 or 5 different examples of ways that you can accomplish that on the Kubernetes site. The way I've been doing it is Flannel, which is built by the same guys who built etcd. So it uses virtual IPs, and that's one of the constructs you get from a service, and I'll get into that in a little bit. And my image won't load. Nice little image. Would have been nice anyway. But kind of it shows a little bit more of the node architecture there. So so as far as the scheduler part of Kubernetes, what it allows you to do is you can treat all of your nodes. You basically just get to ignore them, and the scheduler kind of aggregates them all into one big group of resources. So I got 16 gigs of RAM on my laptop, but if that was a node in a cluster of whatever, 5, you just get to treat it like it's, should have picked a smaller number, 2. You get to treat it like it's just 32 gigabytes of RAM, and it's going to schedule across those. It does orchestration, so this is one of Google's kind of tenets, is that you get to treat your data center like it's a big computer. So when you do a call, whether it's remote or local, that happens relatively quickly when we're talking about network operations. So, and then the container orchestration is an important part of that, especially with service discovery, because that allows you to treat your services as a DNS endpoint, and then there's some reverse proxying that happens in there, and you can scale behind those endpoints as much as you want, and it's not going to affect your end users. All right, so now onto the kind of the key components of Kubernetes, and I can jump back into the demo at some point, or at least kind of explain this in a little more context. So the first unit is, I guess the first real thing is a container, but you never really schedule a container. I don't think you even can schedule a container in Kubernetes. It's all done as pods. And the reason I kind of went into namespaces earlier is that pods actually share namespaces. So we'll pull up. Roll away. But that uPortal container, or that uPortal pod I spun up, for example, has 3 different containers that are actually working in concert there. So, and they're all using shared volumes. So I have there's a concept of an empty directory volume in Kubernetes, which really just kind of on the host will generate a random directory, and then you can share that across multiple containers running in the same pod. So
Another moment. There it is.
Sorry about that.
No one's been doing anything exciting though. Waiting for something fun to happen.
So yeah, you have a shared, I think this is the mount namespace, where I can mount an empty directory in 2 different containers. So one container can actually write some config out to a file in that directory, and then I can mount it somewhere else on a different container in that same pod, which I'm using we have some override files for the portal where I could actually overwrite that with an environment variable that's, because we're reading those in from files, not from the environment variables, but I can say, just write this out to the file, and then uPortal picks that up. And then the other place I'm using that, I can actually show this. No, I can't. So this, if anybody's familiar with Logstash, this is Kibana, which runs with Elasticsearch and Logstash. Let's cycle some of the containers here so I can get some log activity. But what I'm doing here, that's probably going to feel hard, but should get us some logs. This is a separate stack I've got running, which is just Elasticsearch, Logstash, and Kibana. And this should be showing actual logs from the uPortal instances. And the way that's happening is I have the var log directory being written to an empty directory, so that when uPortal writes its logs, that goes to a folder that can then be accessed by this other daemon that'll basically suck up all the log files out of the uportal directory and spit those out into Elasticsearch. So if that didn't feel too hard. Actually, but I mean, I guess you can see at least from one here. This is probably the health check actually. Show the message. Yeah, I'm pretty certain that's. But so this is one example of the way that you can utilize that, and another common example that they give on the Kubernetes presentations that I've seen is like a Git synchronizer. So you have an Nginx container, and then you have a Git container that goes out and grabs the latest, or keeps it in sync with either some branch or some tag, and you can control those separately, so that you get to keep the functionality unique per container. Like we have a web server container, and then we have our Git container, which will go grab stuff and put it in a directory that's being served. So that's the shared volumes. And then the other thing is they're scheduled together. So if you have two things that are strongly coupled that need to run on the same host, this is one way that you can accomplish that. And I think the good example there is the Logstash grabbing the logs out of the same directory. Obviously, you want to have that data locality so that it's not doing a lot of network traffic that it doesn't need to do. So like I said a second ago, why would you do that? You can reuse your containers. Like if you have that Git synchronizer container, then you can go put it on a bunch of different places. It could be synchronizing Tomcat, web app folders, or it could be synchronizing just a plain HTTP or like plain directory structure for Nginx. It could be grabbing Node.js files, whatever. Ground up. Sorry, my keyboard freaks out occasionally, and it just keeps whatever key I just pressed repeating forever. And the other thing this allows you to do is use composition rather than inheritance. So instead of creating these complicated Docker hierarchies with base images and extending and overriding the different file structures, you can just say, I have an Nginx container. It's going to serve out of /var/www. And then whatever you put in there, that's up to you. You just figure out a way to do it. It could be Git, it could be Bash script, whatever you want. So then another construct that I'm actually not sure who was talking earlier, but they mentioned the labels. All right, let me actually try to get these back on the same screen so I can. Bear with me for a second. So I'll share my entire screen now. Hopefully you can see this. So I'll go back to the portal replication controller and forgot what I was actually talking about.
Unlabeled.
That's right, labels. So you see in the template here for my pods for this replication controller, I give it a label of an application. Its name is uportal, and the tier is front end. And so these are arbitrary. You can do whatever key values you want here. And then when you use your service, which we get to in a second, you can actually select on those labels. Open up the service. So here's the selector at the bottom here. So anytime that the app is uportal and the tier is front end, that's going to get grouped into this particular service, which exposes a couple ports. This is for JGroups. And will all be accessed at the same DNS endpoint. So again, replication controllers, I kind of went over that. It keeps your pods in a desired state, so you can say, I want 5 replicas, and it's going to do whatever it needs to do to make sure that you always have those 5 replicas, rather than you having to inspect the state of the system and make sure that you go back and set it right. I like to think of it, and somebody gave the good example of like your air conditioner. You don't say set the temperature to, or like increase the temperature 50 degrees or whatever. That's a terrible example, but rather what you want to do is you give it a desired state. I want it to be 76 degrees, and then it's going to keep it that no matter how hot it is outside or cold it is outside. It's going to make sure that it stays. It's going to turn on the air conditioner when it needs to. It's going to turn on the heater when it needs to. And replication controllers kind of do that for your containers. And then, so there's also the concept of a namespace in Kubernetes, which is different than the Linux namespaces. But this kind of lets you use the same cluster for different applications without having to worry about kind of crosstalk. It's I'm not sure if it's in say or will be soon, but it will actually segregate the networking, so you can't necessarily talk to applications that are in different namespaces. So say I want to run uPortal and I want to run, I don't know, something else on the same application or on the same cluster, but I don't necessarily want I don't want people developing for uPortal to be able to talk to this other application. You can still use that, and you just give them a different namespace. And it also allows you to keep the clutter down, because you can imagine if you have a big enough cluster, it starts to get really crowded at the level of, or with a bunch of different people running their applications on that same cluster. Something or not. All right, well, I don't know if I have my latest slides actually here, but so the next concept is service, which, as I pulled up earlier, what the service is actually going to do is aggregate those different pods. So anything that matches this selector, which, and you can use it for a one-to-one, or you could have, say, I'm trying to think, if you have, say, like a syslog daemon where you want to grab logs off of a bunch of different pods that may all have that same syslog daemon running. You could say, I don't know, syslog true, and then I guess pretend that's on your replication controller you do that. And then you could just say, my selector here is going to be syslog is true. So then when you hit this uPortal service, which basically if you just do a DNS query for uPortal, it's going to automatically grab the IP of this service. Also pull up the output. So you can see here, these are all the different services I have running, and they all get their own IP. In the case of Memcache, that's actually that's what's called a headless service, which basically exposes if I Alright, so I just created a bunch of BusyBox containers. So I should hopefully get the exact thing. So if I do, for example, an NS lookup on uPortal, that gives me the address, the service IP. This is what I'm looking for, of that uPortal service, which is actually the service by default is going to load balance across all the different pods that matches the selector. But you can also do I guess I only have one there. Just a second. hopefully this will start to return a bunch more addresses. You can see that's actually starting to return all the different addresses of each instance of Memcache. So in Memcache, you can do consistent hashing, which it's gonna do its own load balancing essentially across all of those different instances. So that's an example of a headless service. But essentially, services are your abstraction for providing a service to other pods. And then DNS provides a really simple way for you to find out where those services are located. And then that's also, I should be able to ping 10.2.5.65.19. And that's just going to work seamlessly versus if I just pick a random one that's obviously not actually out there. So the DNS gives you a really nice service discovery mechanism versus some of the stuff out there. I think most of the actual implementations end up doing DNS, but one of the nice things with Kubernetes is that that's just built in. You get it right out of the box. So in uPortal, when I give it the database connection string, it's just UPDB because I have a connection or I have a service that I've exposed called UPDB. So there's the instance as that particular IP address. So that should be. This is again, I'm on the host, so I'm going to exec into this container. So that that's going to fit into user. So now we're actually, just by calling UPDB, we're able to pSQL into that, and I can.
That beats what Docker does normally for this stuff.
Oh, we have admins there, and you can. Probably wouldn't diagnose like this, but that's one way that you could. That's actually one of the things I used to diagnose. Just start up a pod and then exec into it. But yeah, I mean, the same thing would happen in your application connection string. You just give it a straight name, and actually, if you look at the resolve conf file, that's actually the namespace I created is called Q. So if we're looking for a service in cluster.local under the namespace Q, and it will create those search namespace or the search. It's called automatically. And then it puts in that DNS endpoint that is going to interact with Kubernetes, find out where all the services are located and where the pods, and actually create DNS entries for those. I think probably about everything I can show off. I don't know if there are any questions, or it's probably a pretty dry presentation. Sorry about that. So.
No, it's good. What are the downsides you've noticed with Kubernetes?
Well, one of the things is it's pretty new, maybe about 1 or 2 years old, so it definitely doesn't have, and it doesn't have quite as many resources, I think, behind it as something like AWS would. It does have significant backing by Google, but I think a lot of people in the community see that as a plus, as a pro and a con, because they don't. I think Red Hat especially is another one of the major contributors, and they're kind of worried about Google taking it wherever they want it to go, because they are providing. And I think there's too a lot of internal meetings at Google right now to discuss bugs and stuff, because there's still a lot of infrastructure, like for testing, that is only Google specific. Like you can't necessarily see why you're testing. Like they'll show off in some of the community meetings this nice dashboard they have. Like, sorry, you can't access this right now. It's an internal Google thing. And then I think along with that youngness, there are still holes in the ecosystem where it's, for example, like how you easily switch back and forth between cloud and local. That's not necessarily something that's easy yet. I think it's definitely way better than the kind of story you would get with Docker Compose and ECS, because you're using the same constructs at least. But there's still like, well, which volume do I use when I'm on? Like, do I need to use a load balancer, or should I use a local port kind of thing? And then a pro and a con, but you don't get as much visibility into like, where is this running? Why is this failing when it's here? Why is it? I've seen a lot of transient failures, probably because I'm kind of doing things weirdly with a host path now on the uPortal case, but seen transient issues like that where it'll work on one node and it doesn't work on another. So I mean, there's benefits and there's cons to extracting all your resources.
Is Docker Compose sort of the other competitor, if you will, to this, or are there others in the open source non-hosted?
I don't know if I would call it a competitor really, because I don't know that. I mean, I guess I don't know much about Swarm. I don't know if that'll use Docker Compose, but that is a cluster management built by the Docker guys. And so if that does use Docker Compose, then yeah, it might be a good way to, or it might be a competitor there. But and I think ECS, you can also say you can give it a Docker Compose file and it'll create you some task definitions based on that. But I haven't played with that either. But yeah, I think this part of the cloud native distinction is that this is built to be on clouds, and as a benefit, you can run it in your local environment, so that you can have that parity. But as far as I can tell, Docker Compose seems mostly it's mostly useful for local development because you're going to link directly versus, and I think it's still pretty hard to do like network links across nodes. Like if you have two different hosts running Docker, you can't, or it's hard to do a link across those two.
You most likely have to have Linux locally for your.
Yeah, that is another downside. It's the same problem that like Charles was on. But anybody with a MacBook is gonna get, seems like severely punished for running on a VM. Like uPortal will start for me in like 60 seconds, and it takes you like 5 minutes.
It's forever.
Yeah,
It's painful.
running on VirtualBox. So yeah, it is one kind of.
So this is the real thing y'all are doing with the production stuff being done in AWS, right?
Mm-hmm. Yeah, so we use Docker Compose locally. It is, at least, I think that's more consistent externally for like the tech center guys that we're supporting, but internally I think everybody kind of has, it was very ad hoc at the beginning, figuring out how everybody was doing it. So.
Because we were all trying to figure it all out.
But yeah, in theory, we should all be running on that Docker Compose file, which kind of binds a bunch of host stuff. But yeah, and then in this case, it would probably be very similar, except it would just be running in Kubernetes on your local host. So instead of, I mean, you'd start up Docker, but then Kubernetes is going to manage that instead of your Docker Compose.
As far as local development goes, I don't know if you kind of had any very rough sense of like, Kubernetes versus Docker Compose. Does Kubernetes just make things a lot slower, or is it comparable?
I mean, and what it's really doing on a low level is talking to the Docker daemons across different hosts. And so it tends to be exactly as fast, with the main distinction being that you're allowed to constrain resources. I'll open up that. So for uPortal here, I gave it a limit of 2 CPUs and 4 gigs, and then it asks for 2 CPUs and at least 3 gigs. But down here on my Logstash, I'm giving it 250 milli CPUs. So it's going to divide that CPU up if you want to do that, and you can. I mean, the memory gets just as granular too. I don't know for CPU. I don't know if you can go down to like micro if you feel so inclined. I just doubt it. I think 1,000 units in the CPU is good enough, but like you can, like if I gave uPortal that, it would take a lot longer to start up. So, but then it's kind of a tool in your tool belt. You can say, well, I don't want uPortal to dominate my resources on my computer because I'm doing other things. So you give it less, or whatever. You can distribute your resources as you want. And really, that too is also something you can do with Docker. I don't know if Docker Compose exposes that, but you can put a flag in your Docker run that'll limit that with cgroups. Yeah, here's the example of I have just a BusyBox container that it's going to get. It's going to put in an environment variable based on the status.pod IP, so whatever the IP of this pod is, and then it's going to write that environment variable to a file, and then it's going to write a static port to that file. And then mount. Yeah, it mounts this phome, which I defined down here in the volume section. So phome is just, this one is actually, I guess, a Git repo. So that's one of the volume types you can use in Kubernetes is a Git repo. So you can actually just pull your config out from a Git repository somewhere in the cloud. And then that'll be exposed as a file system. And that's, I haven't done much at all with secrets yet, but that's another way of exposing secrets is you can just have the secrets written to the file system. So when you give it a secret, it encrypts that, and then you can restrict access, and so that only the pods that are running that can pull that secret out again. And one of the ways you can do that is as a file. So that's really useful for stuff like connection strings where you want to put the password. You want to make sure that that's per environment and that gets mounted. You don't have to worry about that. It's just you put it in the environment and then it gets pulled out by the container.
Very interesting.
So, if there are any more questions about to answer, otherwise I guess we can move on.
Any more questions for content on Andrew's presentation? If not, we'll switch over to, does anybody have any comments or critiques on the presentation itself for Andrew?
I like that it was very heavy demo based, which was cool. Thank you for expanding the text size. That helped me tremendously.
I like that heavy white on black contrast of the slides at first, because some of the slides, like the Unicon deck that people use, I hate that thing. Because it's just, especially on a projector screen, it's just so hard to see. But the nice, easy contrast was nice. But that's a good change, simplified.
I will say, not as much to Andrew, but just because it relates to what you're talking about. This projector is not good. I don't know that we have lots of other options at Unicon, so we have to kind of deal with what we have. The only other real possibility, but you can see these many people would not fit in Mosaic facing that one monitor. We'd love to be able to do it, but we can't all fit in there. And so we're dealt with this projector, which has got a terrible resolution. And so anybody who wants to present in the future, you really should try to get in here and set up and look at the colors and the font sizes before you get in here if you want to do, especially if you want to do live demos. The presentations like PowerPoint or whatever spreadsheet kind of you might have, those auto-scaled pretty well depending on the resolution, but things like terminals are debatable, or worse as you start getting into tools like Eclipse or NetBeans or whatever, and it just becomes unreal to try to find all the different places where you might need to change font size. So I appreciate that you were able to accomplish that relatively quickly, which not a lot of presenters could.
You make a good point. I've come in this room with web pages to demonstrate, not having scaled them to that size before, and they, not necessarily looking fantastic on that display.
Other than that, I commend you on an extremely low count. I wasn't actually paying attention. But, you relaxed, you flowed, your presentation, from a presentation perspective or style, I thought was very natural.
Just knowing that James is going to be counting my ums makes me really
Pressure's on.
See,
if you ever catch me doing the presentation, I tremendously.
I started prepping something and now I'm terrified. Just
Get substituted with
You know, there's actually a reverse to that though, because one of my first jobs, I was at IBM, and there was a guy who tried to, because I was a little peon co-op, and he was trying to, instruct me, and he was the opposite way. He was like, you should think about everything you're going to say before you say it, and the conversation just didn't flow with someone like that. Like, so you say you have a question, the person just kind of sits there and stares for a little while, and they think, I guess they're thinking about what they're going to say, and they phrase that all out before they then speak, and like that's a style. But trust me, I'd rather hear the ums than stare at somebody for 30 seconds before they talk to me. It's really awkward the other way. Trust me.
I've seen it inside out.
Girl.
I did just realize I invited somebody named Andrew.SDE WART2 to our hangout. I didn't know this is spelling it.
Oh, yeah. Sorry.
I didn't see them join us.
I was going to show too, I forgot that I mentioned earlier, this is kind of the Docker Compose of Kubernetes, where it's normally you have one resource per file, but they created a resource type called list, which is, there's no links or anything, but you can go through, I've got my persistent volume and then some claims, and then at the bottom, like services and replication controllers right next to each other. So it kind of makes it, you're only doing, I'll do it delete. So it's all one file versus like having to write a make file out to do a loop over each file.
Why the proliferation of the YAML format as opposed to JSON?
Oh God, right.
You said you like it,
Anyone like YAML?
or why?
I guess I have my leanings, but I don't have a great, it's not awesome reasons.
YAML does have some cool constructs, I'll say. Like, nobody really uses it, but you can do pointers. And then sometimes with bindings will actually make that a pointer. Like if you import, you can use, like basically reuse a section of it, and then kind of like a variable, but it's actually like a document pointer. Yeah.
I just thought everything new these days is JSON everything, JSON everything.
Right. And what it really does is it becomes JSON. So it's just, I think it's intended to be a little more easy on the eyes, I guess.
Yeah. JSON's a little painful when you have all the nested braces. Mm-hmm. It's a little annoying.
I find YAML really hard because you forget a dash somewhere.
Right. Yeah.
Why?
But I've also forgotten commas like 10 million times on the JSON. So 5 minutes into the build, you forgot to take a comma.
Nothing perfect. Sure, Python 10 is
now. Overall, I thought it was real good.
Thanks.
It's definitely a different thing to get exposed to. Yeah. Which I like.
Does anyone work with the I guess with the ECS version of this? Do we have somebody else who's got experience of that?
So running this on Amazon?
Yeah, their whole.
With ECS
yeah.
itself? No, I haven't done. I may have at some point, like on a task desk, but it's been a long time. I've forgotten. But
Ops is
done a lot
like this.
of that.
Yeah. I'd be curious just to see, because it's an initial use case from the developer side of thing, and I think that was a huge bullet point about the the parity between
Right,
Dev and Rod. It'd be interesting to see what their view of this exact, with all the same terms and names and labels and stuff like that. What their side of this looks like. So it's a real thing. It's a real working prod app.
I think in this kind of a model, I don't know if it necessarily fits with the traditional dev and ops separation, where it more like you have, what I've heard a lot is like you have a cluster operations team who's maintaining your nodes, making sure that the networking works well, like designing out all that. And then your developers are actually able to interact with at least most of the environments, and then you maybe automate your production so that you get sign-offs or whatever. But like cluster operations, obviously because it's literally changing a config file to point to a different cluster to deploy to a different environment, like you can do that pretty easily, and it should be a familiar thing when you deploy on production versus deploy on your local machine. Very cool. I don't know, is that helpful?
Yes, definitely.
Well, thank you.
Chris, did you talked about like that video that Franz?
Yeah, and I got an email from him this morning. I had a chance to share with you, but we do have a YouTube video from Franz. It's about an hour and 15 minutes that we will put in as a placeholder if we ever have a dev forum where no one signed up. But he did email me today and say it wasn't critical. So he basically said this is available as a filler, but so I didn't schedule a date because of that email I just got from Franz.
So like an overview of.
It was actually it's more of on a functional programming language why a particular financial services company decided to move to this particular functional. It wasn't as deep a dive on the particular functional language, and more at a high level why they decided to use a functional language, and the reasons are interesting. As I won't get into the YouTube video, but it's more about that and less about the specific language.
So next presentations we'll make sure that we go through a little bit of presentation critique. Charles reminded me of that today, that we did do that for the first few months of this year. So we'll make sure we always schedule time for that. Does anybody have any hot topics that they'd like to see in upcoming presentations? We do have a couple pushed, or a couple slated in the coming months, but does anybody have anything, ideas for somebody else here that'd like to toss out to the forum?
There's still a whole raft of Amazon services that haven't been touched by people that would be good. I heard just the other day, I don't remember what the context was, but like somebody suggested, Amazon's simple workflow would be, would have been a good use for this particular environment. So there's still other Amazon services that people could touch, and some of them aren't that complex to get an overview of.
I feel like you could just take every single service and just copy them right into the schedule and have something at least 15, 20, 30 minutes on everything in there until 2020.
It's not the only thing out there, but I think this presentation today was a great example of a particular, it's very seldom, but a particular case where Amazon was kind of second to the thing. Now, they could have leapfrogged. It's possible, but we don't have the contrary. We don't have the opposite side of this presentation, which is the Amazon ECS thing. But at one particular time, they were behind. Maybe they're ahead now. Don't really know. But on almost all the other services, they're, as Marcus was saying, they're not just ahead. They're like light years ahead, and there's just no comparison. So there's not really this issue of, like, if we were talking about relational databases, well, I don't know if I want to hook my wagon to Oracle. They may not be around in the future. Yeah. No, I mean, the databases are really well established. That's kind of the situation that Amazon's in with most of their services. Most of them are established. You don't have to worry too deeply about hitching your wagon to that, unless it's dealing with a lead leading like sales opportunity where you haven't yet sold the customer and the customer's not positive they want to do it. That's a different situation. But if the customer's already using Amazon, you don't have to worry about using DynamoDB. It's going to be around as long as probably Oracle's around.
So is the compelling use case right now Kubernetes over EC2 instances? You know, you run raw EC2 nodes, or
Is what?
is that the most compelling use case?
I think so, yeah. If you were going to use AWS, and there's a lot of AWS, like there's a whole special interest group on AWS and making sure that Kubernetes can run on that really easily. Like I didn't get into it because I don't have an ECS or an Amazon environment up. But for services, you can just give it type load balancer and it'll use like an ELD or whatever the Google equivalent is. So it's actually, whatever they do to make those highly performant. You get all that if you just put it as a load balancer. And then that can be public. So wouldn't even need it like an ingress.
That's cool.
That's cool.
All right, I guess we're finishing up, I guess, earlier than normal, but unless anybody has anything else, that's it for March. Feel free to sign up. The Confluence page is open for the coming months, all the way out to the end of the year. So.
And also show like here, there's a nice little script out there called I think it's kube-AWS if you Google it, but you can get yourself a nice little Kubernetes cluster really quick if you want to. I think this is on the Kubernetes getting started page, but like I want 4 and 4 nodes and T2 micro for my controller, and it sets up all the PKI for you and makes sure it's all secure. I've played around with that a little bit, but it's too expensive for my taste.
I was just saying,
just to play with it.
Yeah, keep 4 large.
You start with 4 and 4 large. Yeah. Be prepared to fork out.
Yeah. I had that up for about 45 minutes. And I was like,
Gosh,
it's
like
that's
15
enough. Yeah. It was like $2 or something like that.
And Benito had a comment in the chat about I'm not sure what the context of his comments were, but he says, I like that. Which one? I like Clojure.
And he was talking about
The functional front. Okay, functional. All right.
Yeah.
Right.
Sorry, Benito. Just saw the comment. I was going to guess Haskell, but. All right. See you next time, everybody. Thank you.
Thank you.
Thanks, Andrew.